was discussed in that unit, and how to take the best decision or the optimal decision under different environment, like decision under risk, decision under uncertainty. All these various criterias of taking decision was discussed in that class. And another unit, number 8, which I taught was game theory. It was decision under conflict situation, when the competitors are there in the market and they need to take a decision based on the assumption that what their opponent will be doing. So these 2 units was covered by me in the offline class, and the rest 6 units, I've been told that it was covered by another faculty in an online mode.
Roger, ma'am.
Yes. Okay, thank you so much.
Ma'am, I want to ask you, it is a completely a practical subject, na? There is no theory. Is that a theory?
It is a completely medical paper. It is a
okay, thank you.
subject. And
thank you, ma'am.
And what I was telling you, that it consists of 8 units, out of which 2 units was covered by me in offline mode, and remaining 6 units was taught by another faculty in an online mode. Am I correct?
Roger, there is a 10 units. There is a 10 units.
Right, ma'am. That's what I was saying. That's what I was saying. There, and you have covered unit number 8 and unit number 10.
I think one of you will be better because the voice is
actually the mic of the auditorium is on. That's why we are hearing voice to voice.
Okay, so should I mute myself? Then you will speak?
No, okay. She has to mute.
No, actually the problem is not from your end. The problem is from auditorium. I'm sitting in the auditorium right now. That's why we are hearing me twice.
इन्हीं की वॉइस इनको रिपीट आ रही है मैम. ऑडिटोरियम में ना तो वही सामने से माइक से इनकी वॉइस रिपीट आ रही है.
Okay, so I'll speak slowly and I'll speak either I'll speak or one of you will speak, so as it will not echo or it will not clash. Okay, and
you will continue, ma'am. We all are mute. You will continue.
You can raise hand in case if you want to speak, so as I'll get to know who wants to ask anything, and accordingly I'll ask you that one of you please ask your doubts and questions. That will be a good way. And I think one of you can keep a track of the chat. If anyone is writing in the chat and asking for any doubt through chat, then that doubt can be taken from there. So I request Huda, if you can keep a track of any chat which is coming, any doubt which is coming in the chat, and just let me know that what is the doubt. Okay, you can raise hand as and when you feel that you have to ask anything from me.
Hello, ma'am. Hello, ma'am.
Yes. Hello.
Ma'am, you are not on.
Hello.
Yes.
मैम मैं ये कह रहा था कि ये डिसीजन टूल के जो भी इम्पोर्टेंट टॉपिक है वो हमें तो बता दो, जो हम मतलब
Anandji, I think you have changed some setting. Now it is showing me that I cannot unmute or share content. Okay, I think you are doing something from your end. So let me wait for 1 minute, and then once it will be settled, we'll start. I hope others can listen to me. Please raise your hand as and when you have any doubt, or write in the chat so as we can interact. Okay. Okay, thank you. I'll do that. Is my screen is visible? Yeah. So I'm just showing you quickly the syllabus, and as you people are asking that what all topics are more important, or what all we should cover, so as we can make good attempt in the exam. So looking at the topics, one is unit 1 is talking about modeling of, unit 1 is about building the models of optimization. I think in this unit you've been taught how to develop or how to model any decision problem, and for that you've been told how to decide the decision variables, and then how to determine the objective function, and then the constraints in that, and accordingly you will be either formulating a linear programming or a non-linear programming problem. That was the content of unit 1, in which specifically the shortest route problem and the maximum flow problem must have been discussed. The network models, how to model the mod, and by modeling I mean that how to translate any business problem into a mathematical form, so as it can be solved through any of the operation research technique or mathematical technique. This is what we mean by modeling. Okay, so in case if we have any business problem, let's suppose if we have any production problem where you have some resources like the raw material and the machinery and some manpower is there, and you have some space to store the produced units, and now your objective is to maximize your production and maximize your profit. Now how you should utilize the resources, which resource should be most utilized, or how to make your you can say revenue maximum. That is what the objective. So depending on what are you producing, let's suppose if you are producing 10 different type of items which are requiring the similar type of resources or same resources, so the decision variable will be the number of units of each type of items, and then based on the revenue which you are getting from each type of item, you will develop a objective function, and then whatever constraints means the limitations or the foundation, like the things which are limiting you to achieve more profit, so that you will develop. This was taught in unit 1, not by me, but the other faculty has taught this. So just a second, a call from your SOL only is coming. Let me just check if they are asking me to do something. Hello? Garima, I'm taking the class. Hello? Garima, I'm taking the class. Hello, I'm taking the class right now. Okay. Hello? Yeah, Rima, I'm taking the class right now. Yes. So, is it fine? Hello? Yeah, Rima, I'm taking the class. Okay. They asked me to give a quick review. I'm taking a quick review. Okay. 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 So, students, I think this you all must have gone through this content. So, what I was telling you that unit 5 and 8 was covered by me. Right now, has been asked by your coordinator that it would be better if I'll take one unit right now, so as those who join for the first time, they'll be able to at least attend one particular unit and will understand that unit completely. So I'm taking unit number 7, which is Markov process right now. Okay, so let me share with you my PPT for that unit. Okay, is my screen, but the PPT is visible to you? Students?
Ma'am, please open the
Yes,
file.
ma'am.
Yeah, if I'm opening the file, is it visible to you, the PPT?
Yeah, your screen is visible, ma'am, but you
Yeah.
didn't open your file.
My screen is visible. This Markov chain PPT is coming on the screen.
Yeah.
No, ma'am. No, ma'am.
Is it not coming even now?
No, ma'am.
Okay, let me share again.
Yeah, okay.
Is it now visible?
Yeah, now it's visible, ma'am. Thank you.
So the unit which I'm talking about is unit number 7, which is about Markov chains. Okay. So let's start with this unit and let's understand what we mean by Markov chains and how our decision theory, or you can say decision modeling, is taking care of, or you can say it's helping us in taking the decisions under a particular type of situation, which is called Markov process. Before I start, let me first show you what are the contents we're going to talk about in this lecture. I'll just introduce you with the Markov chains. Then we'll talk about transition probabilities, what are they and how they help us in computing the long-term, or you can say the stable state of any system, and then how to follow these steps to reach to the steady state, and some examples I'll take to just make you understand the concept. So as I use the term Markov, here let me tell you, we are going to talk about a particular type, or you can say a special type of models which are based on the probabilistic situation. What do you mean by probabilistic situation? Uh, where I'm not sure about what is going to happen uh, in future, but I have a certain idea about it, that maybe this will happen. For example, today it is raining heavily, and in the morning only I got an idea that okay, because of the rain there could be a heavy traffic, or I'll not be able to reach by that time. So it was probabilistic because I've not exactly seen the situation, but I have just anticipated based on my past experience. So probabilistic means where the chance of happening of any particular event is there, but we are not 100% sure that it will happen, but we have an maybe a rough estimate of its occurrence. So those kind of models where uh, the outcome, or you can say any particular result of that event is not surely known to me or to the decision maker in advance, but he is having an idea about it by just looking at its preceding event, that what has happened in just immediate past. That type of events are called Markov events or Markov chains, or and this type of process which follows such events, which have such type of events, this is called Markov process. That means we are talking about such events where what is going to happen just after you can say right now, maybe just next moment, what is going to happen. What I'm going to do is, for that I'm looking at the immediate past, what has happened in the past, and based on that I'm making an inference. I'm just computing the probability. And if my process, if my business process is based on such kind of a you can say situation where my every next step is depending on what is my present step, what is my present situation. If that is only what is mattering, then that process is called Markov process. For example, in brand switching, you must have seen that, like for example, all of you are having mobile phones. You use mobile phones, and we all used to have some or other, like you can say, we used to make some, we used to give some feedback about it. This is a good one, this is a bad one, or this is having this good battery, or some good features or something like that. So whenever next you're going to purchase, are you going to purchase the same brand, or you're going to move to the another brand? What is that which will determine this? It's only your experience with that brand. Right now, if you're very happy with that brand, you are satisfied with its services, then definitely you may continue with that same brand. Or if you are not so very satisfied, you may switch to another brand. So switching, or you can say moving from one brand to another brand, which is called brand switching analysis, that is basically a situation where not a long-term, you can say, behavior of the customer is required for me to know what he will do in the next step. Next step means whenever he is going to purchase the brand again. But right now, what his present brand is and how likely he is to move from one brand to another brand, that is good enough for me to decide, or to you can say have an idea about whether he remain loyal to the same brand or he will switch to another brand. This is one example where Markov process, or you can say Markov chain, is applicable. Another example would be, yes. Any doubt? Anyone is asking anything? Students, if one of you can keep a record who is asking, then definitely I can answer your questions as well. But right now, what I'm saying is that brand switching, as I'm talking about Markov process, you should know what all processes in the business comes under Markov process, because Markov process is a technical term. You must be feeling that your Markov to ek naam sa lag raha hai. This is definitely a name of a statistician who has studied such statistical processes where movement from one state to another state, that was just dependent on the previous immediate preceding state. If that is a situation, then that process is called Markov process, and also known as, this property is also known as forgetfulness property. Forgetfulness property means you don't need to remember the past for long. For example, at any retail shop, or maybe at any, let's suppose, sweet shop, how many customers are going to come today to buy samosa or any particular sweet? For that, do the shopkeeper have to maintain or record the data of last 10 years or 20 years? Do you think so? Definitely not, because the customers who are going to come today for that particular sweet or for that particular snack, that depends on today's and just day before, or just a day before situation, because it's a rainy weather, a particular season is going on, and in that season, based on yesterday's demand, the retailer, the shopkeeper can prepare the sweets and can plan and can expect, you can say, the number of customers based on his last, you can say, experience. He don't need to remember, or he don't need to record the long past data. If a business situation is there where we don't require long past data, but we just require immediate past data to decide my future plans, or to make out anything about my business. If I have to take a decision about my business, how much should I produce now? Production, definitely my production will decide my profits and many other things. So if that is a situation, that I just need my immediate past data, then that process is called Markov process. For example, in a bank, if at 9:45 there are 10 customers standing in a or waiting in a waiting room for some service, what is the probability that at 9:50 there will be, say, n number of customers? Let's say n could be any 15 value, let's suppose. So that depends on how many customers was there at 9:49, because the difference between 9:49 and 9:50 is just a 1 minute difference, and based on how many customers was there, I can have an idea about, let's suppose if there was 10 customers, then definitely I'm sure that in next 1 minute, not possible that I'll have 1,000 more customers just entering the system. I don't need to keep a track of that how many customers was there day before, how many customers was there 2 months before or 10 months before. So long past data is irrelevant for me. If that is the situation, then this process is called Markov process. Am I clear with this Markov process? What is Markov process? A process in which to find the probability of occurrence of any event, I just require the immediate preceding event information, that what has happened with that event, what was the outcome of the immediate preceding event. If that much is there with me, that is good enough for me to know what will be the probability of occurrence of any outcome for particular event. But other processes, other business problems are like where I have no idea, I don't get any idea unless I have long past data. For example, if I have to find out what is the growth rate of my particular product in the market, so just 1 day or 1 month or 1 week's data is not good enough for me to find out the growth rate. I really need to have a long past record of my product. So there are situations where the long past data is required. There are situations where just the immediate data is good enough. So if the immediate data is good enough, that type of processes are coming under Markov process. Okay, can I proceed now with the Markov process if you are clear? Because this particular unit is talking about Markov chains or Markov process only. Under Markov process, how to take decision, what are the problems which comes under Markov process, that is what we're going to talk about next. I hope it is all clear to everyone. If is any doubt to anyone? Okay, let's proceed. So what are the characteristics of Markov chains? As I told you that in Markov chains, only the immediate past data is required. Now, the possible states means the condition in which I'll find the system. For example, in brand switching, let's suppose if there are two leading brands, say brand X and brand Y, and only these two leading brands are there in the market, and the customer is either using X or he is using Y. Now, if he is using either X or Y, the next time when he has to purchase any product of that brand, either he will remain with X or he will move to Y, assuming that he will not leave the system. It is not, here we are assuming that the customer is not leaving the system. That means it is not that the customer is stopped buying anything, or you can say any new customer is entering in the market. It is the fixed market in which the possible states, that means either the customer is buying brand X or brand Y, they are finite in number. That is the first and foremost important characteristic of a Markov chain, that every time in a Markov chain, the possible states has to be finite and both mutually exclusive. By mutually exclusive, what do we mean? What do we mean by mutually exclusive? Mutually exclusive means that they are totally, you can say, disjoint. They are not having a like as I'm saying that if there are only two brands X and Y, either I will be buying brand X or I will be buying brand Y. There is no possibility that I'll be buying anything in between X and Y. Okay, or both the brands. So they either this or that means mutually exclusive. So another important characteristic of Markov chain is that the events are mutually exclusive and exhaustive. Then the transition probability. What do you mean by transition probability? Transition probability means probability of transition or probability of shifting from one state to another state. Transition means shifting from one state to another state. So if a customer is buying brand X, the probability that he will shift to brand Y, that is called transition probability. So if I have two brands, say X and Y, and the customers can move either from X to Y or from Y to X, then what will be the size of my transition probability matrix? I hope you all understand the matrix term. Matrix means a 2 by 2 or any m cross n representation across the different states. So if I have two states X and Y, there are two brands, then I'll have a 2 by 2 matrix, which will be what? It will be telling me the probability of shifting from X to X, that is remaining with X, or X to Y, or Y to X, or Y to Y. So that matrix is called transition probability matrix. If I have say n brands, so from 1 to any other brand, 1 to 2 or 1 to 3 or 1 to 5 or 1 to n, the probability of shifting from one to any other one, that will be called as transition probability. Okay. So the transition probability depend only on the current state of the system. That means what is the present situation, what is the present state, as in the example of brand right now a brand X user. Now what will be my probability that I will shift to brand Y? That just depends on what I'm using right now. It is not depending on long past data, but right now what is the customer using, that is what matters, and that is what helps us in determining the transition probability matrix. Okay, and some more assumptions like long run probability of being in a particular state will be constant over time. These are the basic assumptions, or you can say basic properties of Markov chains. Now, how a transition matrix looks like, just have a look. As I was telling you that there are different states. For example, of brand switching, if X and Y are the two brands, I will have a 2 by 2 matrix. And right now, as in the screen, it is M. Let's suppose initial states are M. So S1, S2, I'm calling as a state. Initial state, that means, what do you mean by initial state? That means the present state in which the system is now at. So that is the initial state. And the succeeding state means in the next step, in the next time, whenever I'm observing the system again, what is my state of the system at that point of time? That is called as succeeding state. And P11, P12, what are they? They are the probabilities of moving from ith state to jth state. 11 means first state to first state. How you'll understand, how you'll read the P11? P11 means probability of customer moving from state 1 to state 1, and that actually means that the probability that the customer remains with the same state. 1 means one state, he has not shifted to any other state. So P11 means probability of remaining with the same state. P12, what is it representing? P12 will be from state 1 to state 2. What do you mean by state 1 to state 2? Let's suppose state 1 is, right now I'm purchasing brand X. Let's suppose I take example of Samsung and say, let's suppose Apple. iPhone, let's suppose if I am taking example that they are the two only leaders in the market. So Samsung phone, if I'm using, that is my present state. What is the probability that I will be using iPhone whenever I'm buying or purchasing the next phone for me? That would be my succeeding state. So probability of moving from Samsung to iPhone, that if I'm representing Samsung in the first row and iPhone in the second row, so P1, 2 will be what? Moving from 1, that is, let's suppose Samsung, to 2, that is iPhone. Or P21 will be from iPhone to Samsung. P22 means remaining with iPhone. P11 means remaining with Samsung. So this is how we will be reading the transition probability matrix. Now, what is the purpose of reading this matrix? How it is going to help me in taking decisions? Let's come quickly, because this is all the theoretical concept I was talking about. So, as you understand that these are the probabilities, and probability cannot be more than one. So, a customer who is either using Samsung or iPhone, assuming that he is not leaving the market, assuming that he is not stopped using the phone, so definitely he will be using either Samsung or iPhone. So the probability of the customer remaining with the same brand or moving to another brand, the probability has to be, the sum of the probabilities has to be 1, because either of the two definitely will occur. Either he will remain with the same brand or he will switch to another brand. So whatever the situation is, I can say that the sum of the rows of the probability matrix, transition probability matrix, has to be always 1. And the least possible value any probability can take is 0, because the range for probability is 0 to 1. So by 0, what do we mean? That there is no chance that he will buy that brand. If any value anywhere in the transition probability matrix Pij is written as 0, how do we read? How do we understand that? Wherever we are writing 0, that means that particular shift is impossible. For example, normally it is observed that people who start buying iPhone, they don't switch back to any other Android phones. So the probability of shifting from iPhone to Android phone is almost 0. Okay. So what are the steps for transition matrix? First, you need to find out the retention probabilities, then the gain and the loss probabilities, and you'll find out you'll level up the transition matrix. How you do that? Just take an example. I hope my screen is visible, and this is numerical is on your screen right now. If any one of you can unmute and tell me, because I'm just confirming the numerical is there on the screen. Can you all can read out? Yes, Dharmender? Okay, people are giving. I hope it is all clear and readable. So please read this example, and let's try and develop a transition matrix for this example. Two manufacturers, A and B, are competing with each other in a restricted market. Over the years, A's customers have exhibited a high degree of loyalty, as measured by the fact that customers are using A's product 80% of time. What do you mean by this statement? That means those customers who used product A, out of those customers, 80% of the customer remained with A. They kept using A. They repeatedly was using A. For example, let's suppose there are two milk companies. Let's suppose I take example of Mother Dairy and Amul. If I'm assuming that these are the two leading brands in the market, and these are the only two brands, let's suppose, for right now in an example, and the customer who is using, say, Amul, if out of those customers who was purchasing Amul, 80% of the customer remains with Amul, then that is what is called the loyalty, or you can say retention ratio for particular brand. And also in this example, it's given that also former customers purchasing the product B have switched back to product A 60% of time. So construct and interpret the state transition matrix. Would you like to try and write in your notebooks first before I show you what will be the matrix structure? With this information which is there on the screen with the example, what will be the size of the matrix first of all? What will be the size of the matrix? How many brands are we talking about right now? 2. So the size of the matrix will be 2 by 2 because the movement either from the first brand to another brand, first to second, second to first. So that is why the size of the matrix will be 2 by 2. Let's suppose, as in the question, the brands are named as A and B. So the present state means right now what the particular brand the customer is buying. It could be A or B. What will be the succeeding states? That means in the next time, whenever he has to buy the brand, what he can choose from. Either he will remain with A or he will move to B. So the structure of the matrix will be 2 by 2, where the present state will be purchasing A or B, and the succeeding state will be again, he will be purchasing A or B. Now the probability of remaining with A, first element P11, what is P11 will be representing? Students, P11 will be the probability that the customer who was buying A currently will remain with A. That means he'll purchase A again. So as per the information in the question, what is the percentage? It is 80% of the customers are loyal to A. So the probability of remaining with A, that is P11, will be what? 0.8. Am I correct?
Right, ma'am.
Say again.
And the probability of going from A to B will be 0.2 then.
Yes, because obviously if 80% of customers are remaining with A, then the remaining 20% of customers, where they're shifted to, because as the market is restricted, only 2 brands are there. So if the customer is not with A, then definitely he must have shifted to B. So the probability of A to B, very good, Huda. So the example which I was showing you, the matrix will look like this. The present states A and B, the next purchase A and B, the probability will be 0.8 for A to A, that means remaining with A, and 0.2, that is 20% for A to B. And as per the information in the question, B to A is 60%, and so that means remaining with B will be obviously 40%. And as you can see, the sum total of the probability for any row, it is again coming as 1. It always has to be 1. It cannot be more than 1 because the total probability cannot exceed 1. Either the customer will remain with this or with that, but it cannot be more than 100%, right? Is this example is clear to everyone? It was very simple example. How to develop a transition matrix. Now another example for transition matrix. Okay, just let's read this example. In a small town with the 3 advocates X, Y, and Z, each advocate knows that some clients switch back and forth depending on which advocate is available when needed. There are no new clients in the current legal market. However, none of the old clients are leaving the area. This is one of the assumption, particular assumption. I know it sounds a little absurd, but right now what the Marco chain is saying that the market is restricted. That means no new entry is coming in and no existing entry is leaving. That is what the one very basic assumption of Marco process. Now during this we can read it as like, let's suppose if the customers of the bank, if we have fixed number of customers who are right now in the bank, who are the existing, you can say account holders of the bank, and if we are giving some service to them, so that is fixed, you can say that is restricted market. That means the number of customers are fixed, no one is leaving, no one is entering. So during a slack period, the 3 advocates collected data which identified the number of clients each advocate had seen during the preceding years. The result of the study along with the gains or the loss are provided, and the question is to construct a straight transition matrix. Now this is what is given to you. This is a very important and a little tricky question. In this, we are naming the advocates are XYZ, and it is given that they had say 400, 500 or 500 clients as on say January 2008. This was the data of 2008 and 8 to 9. The transition is shown, and the gain is of 75 for X. That means advocate X earlier at the beginning of 2008, he had 400 clients and he gained 75 more clients. And these 75 clients means they are the clients of either Y or Z who has come to X, who has switched to X. And similarly, he lost 50 clients also. That means out of those 400 clients, some 50 clients shifted to either Y or Z. So at the end of the year, or you can say at the beginning of next year, how many clients will he have? X for the advocate X I'm talking about.
425.
Why? Because he gained 75 from Y and Z, but he lost 50 to Y and Z. So ultimately he gained only 25 customers. So he had 400 in the beginning of 2008 and 25 more added. So at the end of year 2008, that means at the beginning of 2009, he is having 425. Similarly for Y and Z, it is the information given to you. So I hope this table is now understandable to you. How and what it is giving you. It is telling you that how many customers been added from other brands. But right now, when the column of gain is there, it is not telling me clearly that these customers, what the X has gained, whether they are the customers of Y or they was the customers of Z. So that information is given in the below table, where exact information of that these 75 out of these 75 gain customer for X. The bifurcation was that 50 customers was gained from Y and 25 customers was gained from Z. And again, the 50 loss of X, that means the customers who moved from the advocate X to either Y or Z, where they had gone to which particular advocate they have shifted to, that information again is given in the below table under the loss. So X has lost 50 customers to Y. Is this table is now understandable? Can you make out what is the information given in this table?
Yes,
Please
ma'am.
look at the screen and because this information is going to help you to develop the transition probability matrix. Now, what will be the size of my transition probability matrix for this numerical?
3 cross 3.
3 cross 3, very good, because there are 3 advocates XYZ, and as per the information, the clients are either remaining with the present advocate or they are shifting to the other 2 advocates. Either of the 2 will definitely happen. So the 3 by 3 transition probability matrix will be there. And what we need to find out under the 3 by 3 matrix, let's suppose XYZ are the present state, and by present state we mean that the advocates under which the client is under right now, and the succeeding state will be again XYZ. That means the advocate to which the customer, or you can say the client, will now switch to. Now, what will my P11 will be representing? What is my P? Yes.
Going next to
The client which was under the advocate X and remained with X. That means जितने customers X advocate के थे और वो X advocate के अंडर ही रहे, नेक्स्ट टाइम भी जब उनको कोई केस लड़ना था तो वो X के अंडर ही रहे, वो कितने थे, कैसे निकालेंगे लॉयल्टी? P11. Just think about it and develop a 3 by 3 matrix. Take your time of 1 minute and at least tell me few probability values, P11, P12, if you'll be able to make.
Ma'am.
Yes, Sudha?
Yes, ma'am. So P11 is going to be 350 over 400.
350 over 400.
Yes, because X lost 50 customers.
Because listen,
X
everyone listen very carefully. The advocate X had 400 customers, right? Out of those 400 customers, 50 switched to either Y or Z, and 75 came from Y and Z to X. But out of those 400, if I subtract 50, वो जो 50 लोग किसी और एडवोकेट पे ट्रांसफर हो गए, उनको हटा देती हूँ क्योंकि वो लॉयल नहीं थे. तो 350 जो थे, out of 400 I subtracted 50, I got 350 as a number. This 350 number, or you can say these number of clients, they are loyal to A, loyal to X. So loyal customer हो गए 350 out of कितने 400 में से. So this is what is giving me the P11. Okay, and now similarly I need to find out what next is my P12. I'll show you. This is how we're going to develop number of lost, number of gain, number of retained. Abhi just now Huda was telling you that the P11 will be what? 350 divided by 400, and it is coming as 0.875. Similarly, for Advocate Y, there was 500 customers at the beginning. He lost 150 and he gained 350. So what will be the loyal number of customers for Advocate Y?
350 again, because he lost
500.
150 out of
350.
right.
How we got 350? Because out of 500, 150 shifted. So the number which retained by Y was 350 divided by the number of customers who was there with Y. So 350 divided by 500. So these values which are 350 divided by 400 or 350 divided by 500 and 475 divided by 500. What are these values are? These are the loyal customers of X, Y and Z. Where they will come in the matrix, they will come in the diagonal form P11, P22 and P33. Can you see that? 0.875 at P11, 0.7 at P22 and 0.95 at P33. This is what is calculated with the above table. Now it comes to the shifting. How many customers shifted from X to Y? As per the information, 50 customers moved from X to Y. So the probability will be 50 customers entered to Y, and how many customers was there with Y? 500. So 50 divided by 500, that will be the probability of customer switching from X to Y. So that will be P12. Similarly, P13, that means shifting from X to Z. How many customers shifted from X to Z? 25 as per the information in the table. I'll show you the table again. As you can see, the gain. Y has gained 50 customers from X. Z has gained 25 customers from X. And so the probability are computed based on the information given, and then it is being compiled in this table, and this matrix which is right now on the screen is called the transition probability matrix. Yes?
No, ma'am, it's okay. I got confused actually, but it's okay. This is fine.
So with these two examples, is the transition probability matrix construction is clear to you? How you need to construct a transition probability matrix? In short, we call it as TPM. T for transition, P for probability, M for matrix, TPM. So how to construct any TPM? Is it clear? Because this is what you can expect in exam also. It may come as a numerical that you are given with a certain information and you need to construct a transition probability matrix. That is the first and important step of any Markov process, because first we need to have a transition probability matrix. With that, we find out many other things, but unless and until you been able to construct a transition probability matrix correctly, you will not be able to do much in the Markov process. So should I proceed? Or anyone is having any doubt under the transition probability matrix? Students, I request you to please go through with your syllabus and see the different examples of TPM, and please practice more questions for developing a transition probability matrix. As I understand that most of you are interested in knowing that what are the important topics which may come under the exam, and how to do that. That is what you are actually was asking me in the beginning also. So this you can expect as one of the important question, that the information is given to you and you need to develop a transition probability matrix. Okay. So as no one is asking any doubts, so that means this transition probability matrix computation is clear to everyone. So I'm proceeding. Use this transition probability matrix for taking the decision under Markov process. Okay, so take an example. There is a survey which has found that the mobility of the population of state of to a village, town or city is in the following percentage. Yes, I hope you all can read this. So please first read the question and then we'll discuss what has been asked in this question. With this information, what all you make out, what is the information given to you, that what is the mobility in terms of percentage is there from the village, town and city to a village, town and city. So how we'll read this, that means 50% of the villagers are remaining with the village, that means they remain in the same village, and 30% of the villagers are moving to town and 20% are moving to city. This is how we'll read this transition matrix. This is actually not in a transition matrix form. This is not a probability matrix, but it is a number matrix where the percentage wise shifting is given. But definitely, if I just put a point, a decimal before each number, it will be converted into a transition probability matrix. Am I right? Yes, students? Have you read this question? If you have read this question, so now we can move to the solving part of it. Just read it quickly.
Ma'am, I
Yes.
have one question here.
Yeah.
This probability of moving, it is given in the context of a single year, as in 1 year, 50% of the villagers stay in the village, 30% move to town, and 20% move to city.
Right.
Is that what is meant by this?
Exactly. It is given that presently, whatever, let's suppose if there are 100% of the population which is there in the village, out of those 100%, this 100% could be any number. So how many percent of the villagers are moving to town or city? That is what the percentage is given to me. That means presently, as it is being surveyed, this is the situation. This is the current state, you can say, the present state in which the system is in. And in the next state, it could be after another 1 year, I'm again observing how many customers are, how many people who was residing in village or town or city. Out of those, how many remain with that? So that will be the next state. We call in Markov process, these are the states. That means different conditions under which I found the system in. Okay. Yes, Sudha, is it clear now?
Right. I just wanted to understand that this probability is given for a single year. Yeah.
Yes, as I mentioned to you, in a Markov process, whenever the TPM is given, the transition probability matrix, it is for one step. That means that one step could be after 1 year. It could be if it's a purchase of say a milk packet, it could be just 1 day. After 1 day, that means when the next time purchasing. So that period could be of 1 day, it could be of 1 hour, it could be of 1 month or 1 year, whatever the period which we are following in that process. So thank you so much, Uda. So that means through you, I'm getting the information that yes, students can listen to me. I request
Right.
everyone to please pay full attention. Don't feel that I'm not standing there or that no physical teacher is there. So they may be like just not listening to me or not looking at the slides much deeply. But request you, as you all invested a lot of time in coming, and I'm really sorry for today for the reason that it was raining very heavily, and so that is why I could not make out to reach there on time, and I that in the morning only I was like confused what to do. Thanks to the coordinator who at the last moment made this arrangement, so at least two people who all came from so far in such a extreme weather, at least your time was not got wasted. But yes, sorry from my end for this extreme behavior, because I was not anticipating that this heavy rain will be there, and again it's a tree again for the village movement from village, town and city. Now the question was asked that what would be the situation, or you can say what would be the proportion of population in town, city or village after 2 years. For that, what is the present proportion that is given to us in the numerical, which is 70%, 20% and 10%. This we had written as in the matrix form. This is one information which is present. And then the next matrix, which is what? It is a transition matrix. Now it is being converted into transition. Can you all see that? Be easily converted into a transition matrix. So after multiplying the present proportion with the transition matrix, to multiply the two matrix, what is the
ma'am, it will be helpful if we could go over that once more.
Online class.
Kuldeep, you saying something, but I cannot hear you clearly. Can you speak again? A little loud.
मैडम ये बच्चे आ रहे हैं कुछ क्लास के अंदर उनके लिए
I'm really sorry, your voice is coming but not clearly. I cannot make out what are you speaking. Huda, as she was.
Ma'am, even I can't understand what he's trying to say by mistake. I'm not able to understand what he's saying.
Kuldeep, if it is a doubt regarding this question, what you can do is you can write in the chat, and maybe Huda can read out. If it is something else, hear you.
What?
If you are in the auditorium, you may pass your doubt, or you may come ask your doubt to Huda. If you are in the auditorium, if you are from your home, if you are attending this class, then maybe you can write in the chat, or I'll provide you my number. You can write to me. Even after that, you speak with me after the class. You can ask the doubts as and when you want.
Can please switch back to the slide number 14, please, once. The question.
Question of this particular solution.
Illustration 3, slide 14.
The matrices you are done.
This is what you're saying?
Yes, ma'am. So I just wanted to. No, ma'am. I'm attending online. So okay. I just wanted to see if.
But sorry, till now I cannot make out what Kuldeep wants.
That's okay, ma'am. I am done. Yeah, you can.
Okay. So
thank you.
So with this example, we had computed after 1 year. Now, what we'll do to compute after 2 years?
The result.
We will multiply with transition matrix.
Yes, very true. So that whatever the proportion we got after 1 year, that we will now use to multiply with the transition matrix, and that will give me the proportion after 2 years or after the second year. And similarly, if I multiply the proportion after the second year again with the transition matrix, then what do I get? The proportion after 3 years, and so on. Now, one thing was observed with the Markov analysis, that if we keep multiplying this way, that I got a proportion after 1 year and I'm multiplying with the TPM to get the proportion after 2 years, and then the 2 year proportion multiplied the TPM again is giving a proportion after 3 years, and so on. It was observed that after some few, very few, just maybe 8-10 number of multiplications, repeated multiplications, you will see that the proportion will become almost steady. It will remain same every time. That means, what I mean to say is that when I multiply in this similar manner again and again, say after 5 number times or 7 number of times, I will see that there is no much the situation, the you can say problem in which we are actually applying the Markov, that has reached to a steady state. By steady state, I mean that constant, stable, or equilibrium state observed. So what do we mean by steady state? Steady state means the state at which the proportion is not changing. That means जैसे अभी हमने initial proportion को present proportion has been attained when the change in the proportion is not much. It is hardly, it is almost equivalent to 0. And that particular state of the system is called the steady state. Or that means it is almost a state at which the system has reached to a equilibrium. That means constant, at a constant level. That means no much now shift, or you can say no much change in the proportion is now observed. Am I clear with the steady state? Because this also, you may be asked to compute the proportion after any number of periods, like 2 periods. In this particular question, it was after 2 periods, that means after 2 years. It could be any number for which you may be asked in the exam, or you may be asked to compute the steady state. Steady state means again that particular state in which the change is almost much change in the system is observed. How to compute the steady state? One way is, as I told you, that keep multiplying this result with the TPM to get the result for the next period. एक ही चीज को मैट्रिक्स मल्टीप्लिकेशन कितनी बार करेंगे? एक बार, 2 बार, 3 बार, 10 बार करना. It sounds like only 10, but yes, it is difficult to do that with the help of Chapman-Kolmogorov equation. Which state this particular equation, what it helps us is, it says that the equation states that the n-step transition matrix may be obtained by multiplying the transition matrix P by itself n times. How to read this? ये आपको शायद अभी इस statement से इतना clear नहीं हुआ. Let's apply this in example that will make you understand this Chapman-Kolmogorov equation. Take an example. I think this is a good example for transition matrix B. We are given with the matrix that rain or no rain. आज बारिश हो रही है या नहीं हो रही, और उसके हिसाब से कल होगी या नहीं होगी. अगर मैं उसका फोरकास्ट की बात करूं, प्रोबेबिलिटी की बात करूं कि कितनी चांस है कि कल होगी या कल नहीं होगी, वो आज की कंडीशन को देखते हुए, आज का ह्यूमिडिटी, टेम्परेचर एंड ऑल अदर फैक्टर्स व्हिच अफेक्ट्स और व्हिच डिटरमाइंस वेदर इट विल रेन और नॉट, if they are been analyzed, then the T% and it has not rained, there will be no rain tomorrow as well. The chances are 60%. Now, if we need to calculate that what will be the we can say chance that applied 4 times, to multiply this PTM, this TPM 4 times, or you can say to raise this power of this T same, or P to power 4 is same. And this helps us in finding out the steady state quickly. How? As I was talking about the steady state or the equilibrium condition, quickly you can read the slide. As the number of periods increases, further changes in the as the small number of states. यहाँ पे infinity मतलब mathematical infinity नहीं है कि आपको infinite number of times multiply करना पड़ेगा. Normally this infinity here means a large number which could be even maybe 7, 8, 10. State condition only if the transition matrix remains positive. This is one condition, and it is possible to go from one state to another state in finite number of steps. This property is called ergodic property of Markov chains. How to find the steady state and what do you mean by that? That let me show you through the next. Just read.
Yes, ma'am. Yes, ma'am. It is visible.
On January 1 this year, bakery A had 40% of local market share, while the other two bakeries B and C had 40 and 20% respectively. Based on the study by market research firm, following facts were compiled. Bakery A retains 90% of its customer, while gains 81 next year. That means after one period, I can say. And what will each firm's market share be as the steady state or the limiting state share is being asked. The two parts are being asked in this question: after one period and the steady state probability. The first step, what is the first? We need to develop the matrix with the information given to us. Please, I request everyone transition probability matrix TPM first with the information. What will
3 cross 3 again.
Very good, because there are 3 bakeries under the consideration, and so A presently customer P11, where 11 is representing that the customer who was with A will remain with A. How much?
So it will be 90%, so 0.9.
0.9. As it is written, bakery A retains 90% of its customers. From this information, I will write P11 as 0.9. Now, we'll gain 5% of B. That means B to A, P21, the second value, P21, 5. And 10% of C. That means from C to A. And C to A means third row, first column. That will be 0.1. Now, bakery B retains 85%. That means B to B. That is P22. If second row is representing bakery B and second column is again representing bakery B after one period, then 0.85 will be the value of P22. I hope, as I right now cannot expression, so I cannot make out right now how many of you are getting. So anything related to this, what I'm teaching right now, if you have any doubt, what you can do is you can share with me to WhatsApp. My number is 98100 13343. Just write your doubt and maybe your name, or at least you just write the SOL student. That is good enough for me to know that yes, one of the SOL student is asking me, because as I teach in college as well. So according to your doubt, I either will be answering you through WhatsApp if you need to discuss it, so as you'll be able to understand much clearly. I'll either give you a call back or I'll ask you to call me. Okay.
Can you repeat that number, please?
Yeah, it's 98100 13343.
Thank you, ma'am.
Okay, or you can email also to me, whichever way you find most convenient. My mail ID is my name, Amrina Kasur, at sscbsdu.ac.in. I repeat, Amrina Kasur at sscbsdu.ac.in. Do mention at least your name and the course which you are from. Okay, because it should not get mixed with the other students' query. Okay, so I had 40%, bakery B is having 40% and bakery C is having 20%. That means अगर पूरी market में जितने भी customers हैं, अगर उसको हम कह देते हैं, they are 40% are using A, 40% are using B, and 20% are using, very similar to the previous example of shifting from village to town.
Ma'am, could you repeat what you just said? Are you asking a question?
So that how you will compute the share after one period, after 1 year?
By
Multiply by the
multiplying.
TPM.
Yes,
Right.
we will multiply the present share, which is 40, 40 and 20, that is we'll write 0.4, 0.4 and 0.2 with the TPM to get the share after one period. I'll show you. This is how we're going to do. So market share after one period will be the market share at present into the TPM. So after 1 year, what has been observed? 40% of the customer which was there, they will remain with A. 37%, that means you can see that B is losing some customers and C is getting a better share. He had 20% share of the market. Now after 1 year, he will have 22.6% share of the market. That means you can say that B is going % and C is going to gain. Now, how to compute after? How to compute the equilibrium state, or after say n period? What will be the share? For that, see what is it being done. This is important for you to understand. Let's suppose I am not knowing that what will be the steady state or what will be the equilibrium market share. मतलब जब कांस्टेंट हो जाएंगे मार्केट शेयर तो वो क्या होंगे मुझे नहीं पता. मैंने उनको बोल दिया लेट्स सपोज दे आर A, B and C. जो ABC लिखा है ये कोई नंबर्स आने हैं, जो n नंबर ऑफ टाइम मल्टीप्लाई करने के बाद जब कांस्टेंट हो जाएगा, जब लिमिटिंग पॉइंट पे हम पहुंच जाएंगे तो जो वैल्यूज होंगी वो मैंने कहा कि वो ABC, इसको ABC भी लिख सकते हैं, इसको आप XYZ भी या PQR जो भी आप नोटेशन रखना चाहिए। यहाँ पे सिर्फ हमने बेकरी की वजह से ABC लिख दिया क्योंकि बेकरी का नाम A, B और C था। आफ्टर n पीरियड मान लीजिए मार्केट जो है वो इक्विलिब्रियम स्टेट पे पहुंच रही है, इसका मतलब हुआ कि n-1 पीरियड से n पीरियड में जब शिफ्ट हुआ तो चेंज ऑलमोस्ट 0 था, क्योंकि हम स्टेडी स्टेट उसी स्टेट को कहते हैं जब हमारा चेंज होना, स्टेट में चेंज जो है वो ऑलमोस्ट 0 हो जाए। अब स्टेट में कोई चेंज नहीं हो रहा, प्रोपोर्शन जो है वो ऑलमोस्ट कांस्टेंट हो गया, फिक्स हो गया कि अब मार्केट शेयर ये रहेगा बिटवीन द 3 ब्रांड्स। अगर ABC n पीरियड के बाद का शेयर है और n-1 पीरियड और nth पीरियड में कोई डिफरेंस में भी ABC शेयर रहा होगा इनिशियली, तो अगर n-1 पीरियड की स्टार्टिंग में ABC था और फिर उसके नेक्स्ट पीरियड यानी कि nth पीरियड में फिर ABC आया, तो जैसे हम पीछे मल्टीप्लाई कर रहे थे कि प्रेजेंट शेयर को TPM से मल्टीप्लाई किया तो नेक्स्ट पीरियड का आता था, फिर नेक्स्ट पीरियड को फिर से TPM से मल्टीप्लाई किया तो उसके नेक्स्ट पीरियड का आता था, एंड सो ऑन। तो इसी तरह से अगर हमने n-1 पीरियड के TPM को मल्टीप्लाई किया, प्रोपोर्शन को मल्टीप्लाई किया TPM से, तो उससे क्या मिलेगा, nth पीरियड का TPM प्रोपोर्शन मिलेगा। एंड क्योंकि n हम किस स्टेट को कह रहे हैं, जो स्टेडी स्टेट है, कांस्टेंट स्टेट है, दैट मींस n-1 पीरियड के प्रोपोर्शन में और nth पीरियड के प्रोपोर्शन में कोई डिफरेंस नहीं होगा। और इसी रीजन से यहाँ पे ABC जो वैल्यू है वो सेम लिखी है, दैट मींस n-1 पीरियड में जो प्रोपोर्शन था और nth पीरियड में जो प्रोपोर्शन है वो सेम रहा। तो वो ABC क्या वैल्यू है, कैसे निकलेगी, उसके लिए मैं यहाँ पे इनकी इक्वेशंस बनाऊंगी। कैसे बनेंगी ये देखिए, मल्टीप्लाइंग द टू मैट्रिक्स। तो लेफ्ट हैंड साइड में आपका, मैं फिर से दिखाती हूँ पिछली स्लाइड, लेफ्ट हैंड साइड में ABC ये 3 प्रोपोर्शंस लिखे हैं, तो फर्स्ट वैल्यू A की वैल्यू कैसे निकलेगी, A विल बी द राइट हैंड साइड ABC वैल्यूज विद द फर्स्ट कॉलम वैल्यूज, that is 0.9A plus 0.5B, 0.05B plus 0.1C will be equals to A, and this equation and third equation. Fourth equation जो लिखी है A plus B plus C is 1, ये एक जनरल इक्वेशन है क्योंकि हमारा assumption है कि हमारी मार्केट जो है वो फिक्स्ड है और उसमें कोई गेन या लॉस नहीं हो रहा, यानी और कोई कस्टमर इन नहीं हो रहा और कोई कस्टमर आउट भी नहीं हो रहा। दैट मीन्स द टोटल शेयर, द टोटल प्रोपोर्शन between A, B and C is 100% and that is 1. अब ये 4 इक्वेशंस हैं और A, B, C हमारे वेरिएबल्स हैं। जैसे हमने मैथ्स में आपने स्कूल लेवल पे X, Y, Z लिए होंगे वेरिएबल्स, अगर 3 वेरिएबल्स हैं X, A, B, C और you can see the variables. So after solving these 4 equations, you may use any 3 also, and they are good enough for computing the values of ABC, and through that you will get the values of ABC here as 43%, 28% and 29%. And what are these values representing? They are the steady state market share. That means constant. When the market becomes constant, what will be the share between the 3 brands? A will be having 43%, B will be having 28% and C will be having 29%. Am I clear?
Question, just one question. If you can go to the previous slide, where you mentioned ABC and ABC on the left hand side and right hand side.
Yes. This one?
Yeah, this one. I mean, on the first view, to solve this equation, the view I get is the TPM should be a unit matrix. Then only the left hand side would be equal to right hand side. Now, are we saying that to solve this, there are 2 solutions? One is what you have found in the next slide, and the other is, where ABC remains the same, but the TPM is unit matrix for this equation.
No, just a 1x3 matrix. Okay, not multiplied with any unit matrix. It is just a side. There's a 1x3 multiplied with a 3x3. Okay, and
Yes.
The result of 1x3 into.
I'm just viewing it from a perspective at the right hand side here. This I mean, instead of TPM, if I take a unit served.
Same result.
Right.
But yes,
yeah.
That will
So there are two
same.
results to this solution, right? There are two solutions to this. One is
Atul, unit matrix is like a number 1. Multiplying anything with a number 1 will not make any change in the number as the multiplication. If I write just 5 or I write 5 difference.
No, I mean, that's precisely the behavior I'm trying to.
Is ABC and is equals to ABC times a TPM. Now, when I multiply the ABC with the TPM on the right hand side, I will get what? The size, the result in terms of the result size of the matrix, it will be a 1 cross 3 matrix. Am I right? Because multiplying a 1 cross 3 with a 3 cross 3 will give you a 1 cross 3 matrix. And 1 cross 3. So comparing a 1 cross 3 matrix with a 1 cross 3 matrix is very much possible and correct. And so I will get one answer for A, one answer for B, one answer for C by just comparing the two sides of the results. So there is no place where I'll be using or I'll be requiring any unit matrix. And as I said, that unit matrix is nothing but just like number 1 of your mathematics, which when multiplied with any number is not going to change. So there is no need of writing. Multiplying 5 with 1 or dividing 5 by 1. I never write 5 as 5 by 1 because I know that 5 by 1 is 5 only. So, but in fractions, we may write 5 as 5 by 1 because if I want to show it is in terms of fractions. So similarly, here matrix on the left hand side is a 1 cross 3 matrix. Matrix on the right hand side is again going to give me a result of 1 cross 3 matrix, which can be compared to get the value of A. Confused with ABC as like why? What are these ABC? They are the you can say steady state share between the 3 brands A, B, and C. You can call it as XYZ also as the variable names and
TPM. So what I think is it is
identity matrix. Atul, okay, if you want to understand it this way, let's suppose if my TPM is a identity matrix, that means my first element P11 will be 1.
Yeah.
And P11 means the main with 1.
Yeah.
That means no.
It will remain the same.
And P12 and P13 are 0. Similarly, the shift from 2 to 1 is 0 and 2 to 2 is 1. That means all the customers of B remains with B. Right. All the customers of C remains with C. If that is a situation, then actually it is happening.
True.
Right.
No, I'm just interpreting it.
Situation. It could be a situation that my market is such that all the customers are sticking with the same brand. But in that situation, अगर मेरी मार्केट की सिचुएशन ये है कि 3 ब्रांड्स हैं और जो कस्टमर जिस ब्रांड को खरीदता है वो उसी को खरीदता ही रहता है हमेशा, कभी मूव ही नहीं करता, उस केस में तो मुझे कोई एनालिसिस करने की जरूरत ही नहीं पड़ेगी ना. उस केस में तो मुझे ये क्वेश्चन ही नहीं आएगा कि 1 साल बाद क्या होगा और 10 साल बाद क्या सिचुएशन होगी, क्योंकि वो तो एक स्टेशनरी कंडीशन, एक ऑलरेडी फिक्स्ड इक्विलिब्रियम कंडीशन शुरू से चल रही है कि कोई
ओरिजिनल मैट्रिक्स. And as a result, it is actually has become redundant to a unit matrix only. I mean, I know, there is an actual, it is actually has become redundant to a unit matrix only. I mean, I know, there is an actual change, there is actual transition, but the final numbers after the transition remains constant.
If the result is showing you that no change, does it mean that there's no movement or no between the states? Yes. Kuldeep, you want to speak something?
I want to inquire. जब ये राइट साइड पे